following students to high school authors: Bryce Burnett, Connor Burrow, Kenyon Clifton, Jay Pearson, Banner Hennigan, Hayden Hilton, William Hope, Logan Hubbard, Carson Humphrey, and Michael Poe.
I wonder what they're doing.
I saw the leather jackets in the office. Maybe those people ordered one of them. I don't know. That's just a guess. I don't know.
That is a drug test.
It might. Usually don't do it that soon. They did one not long ago.
Yeah, no, maybe they're like suspicious
Yeah.
of them doing marijuana. Or crack.
You want to? Oh no, I feel like I've been through one. Wow.
What are you doing?
Alright, we've got, shh, be quiet. We got 1 over F equals 1 over P plus 1 over Q. Well, hey, you're about to get on my nerves. What we've got here, it says in physics, the focal length F of the lens is given by that formula. P is the distance from the object to the lens. Q is the distance from the lens to the image. Okay? We're going to solve for Q when our P is 20 centimeters and our F is 10 centimeters. Okay? So first thing we need to do, we're just going to substitute this stuff in. So I've got 1 over F, so 1 over 10 equals 1 over 20 plus 1 over Q. Now this problem becomes the exact same type of problem that we did yesterday. We got to figure out what the common denominator will be and then multiply it by that to cancel all the fractions out. So I'm looking at 10, 20, and Q. What will they all three go evenly into? Oh, 10, 20, and Q go evenly into. Same stuff we've been doing. 20Q. So we multiply the whole thing by 20Q. Alright, when we take it here, 20 over 10 reduces to 2. Okay, follow this. I think some of y'all have been missing it. 20 over 10 reduces to 2. So that's 2Q. Because 1 times 2 stays 2. Right? Okay, now we go equals. When we go here, 20 over 20 goes away. All we got left is Caleb's right at Q. Okay, what cancels when we go here? On that last little jump. Just the Q. Very good. Okay, now we got a good old normal equation to solve. What would we do here? Subtract the Q. Rachel, this is correct. She wins bonus points. Sucks for the rest of y'all.
I'm the following students to the high school office: Jared Kohler, Riley Burkett, Corey Duenas, Joseph Gowdy, Kaylee Sutherland, Nicholas Layton, Grace Blunt, Kenzie Blunt, Hayden Britt, and Haley Webb.
Good.
No.
Nope. She's just kidding. Alright, good on that? Going to take that same formula now and do something different with it. Same formula, 1 over F equals 1 over P plus 1 over Q. This time we're going to solve that equation for P. Okay, that means we want to end up with something that just says P equals at the end. Not going to have a number answer, and this is where you've always struggled in the past in Algebra 2 at when you don't get a number answer. Your answer is going to look more complicated than what we started with. But the first dilemma is still the same. We got ugly fractions. We got an F, a P, and a Q on denominators. So what can I multiply this whole fraction by that would take those out? What will F, P, and Q all go evenly into? F, P, Q. Very good. Isn't that crazy to say that? But that's right. Alright, so figure out what cancels when I go to this first piece. The F's will cancel. So I'll have 1 times P times Q. Capiche? Equals. When I go to the second piece, the P's will cancel, so I got 1 times F times Q. Alright? When I go to the third piece, the Q's cancel, so I got 1 times F times P. Don't lose sight of what we're solving for. On the top right, I wrote a little P. We're solving for P. Dilemma that you should notice now is you got 1 on the left side and you got 1 on the right side. if I'm gonna be able to solve for these anyway, I need them to be together on the same side of the equal sign. So what could I do to make my p's both be on the same side of the equal sign?
Take out P to the other side.
Do,
Divide by 2.
subtract it. Subtract, we'll move it over there. So I'm going to subtract FP from both sides. Over here, what's PQ minus FP? I don't know. I'm just going to write it as PQ minus FP. Then over here, I got FQ. I move that dude out. All right, we're solving for P. This next step is a pretty crucial one that y'all forget every year. Trying to solve for P. Both of these have one. So I'm going to, what have we been doing most of the time in here since Halloween? Factoring, very good. Hayden, I'm going to factor that P out. Wouldn't these be the same thing? The reason that was a great move by Hayden is because I'm trying to solve for P. Now it's being multiplied by that, so I just got to divide by that. So P is FQ divided by Q minus F. Can I ninja anything out here? First period wanted to try. No, Zane's right, you can't because this is a monomial and this is a binomial. Can't pick apart a binomial, that's it. Hey. That's not the main gist of the lesson, but that is a little important part of it. Okay? Ready to jump in some of the word problems? Of course you are. Alright, we got an old stat here. In 2003, about 15 of over 100 Americans had no health insurance. The population at that time was about 288 million. How many million Americans had no health insurance? Alright, so when we counted them all, put them in sections of 100 people all around the planet, or all around the country, 15 out of every 100 did not have health insurance. It said the total population in the U.S. that year was 288 million. Well, my little populations were 100, so that's what the 288 million needs to correspond to. How many did not have insurance? That's what we're trying to figure out. What's that called you just wrote? Starts with a P. Uh-huh. What'd you say? No, it's not parabola is a U graph.
Oh yeah, that's it.
Proportion. Thank you, Rachel. Two fractions equal to each other, that's a proportion. What's the most common way to solve a proportion? Cross multiply. Very good. I'll do this one first because I know it. 100x. I don't know this. Help me out. What's 15 times 288?
Yeah, I got it. Oh, 4,320.
So then to solve for x, being multiplied by 100, so divide by 100, and x is 43.2. Now, so 43.2 people did not have health insurance? No. I said that was 288 million. So this would be 43.2 million people didn't have health insurance.
That's just sad.
Yep,
They're really sad.
that's what Obama thought.
That or nobody should.
Is
You just wouldn't
it
need it.
expensive?
Yeah,
Everything's expensive.
mine is not as bad as a lot of people's.
Why are
Just-
some people's cheaper than others?
Because schools are a state agency, and so it's like the state pays part of ours, and our school pays part of ours. Because
Some
if-
jobs get
Right.
benefits.
If you're sick all the time, then your job's going to suffer. So those people will like try to help you stay well by providing you with insurance.
That makes sense.
Yeah.
So like,
Yeah.
Like there's some jobs like if
What
you own your own business, you're on your own. I mean, nobody's kicking in, so it costs you more
Dang
than.
it, Mike. You hear that?
what if?
Put that chair down.
Oh, I'm sorry.
What happened? She tells you that
I know,
every
but
day.
that's why they all been breaking.
So when you like apply for health insurance and they ask you like if you smoke, what if you lie?
I don't know.
Why? Do you smoke?
I mean, I don't know that they would, unless they like do a physical and hear that you can't breathe. I don't know how they would ever know. I don't know. I was never asked anything like that. I just was asked.
I just know because Stan and Toler's dad does our insurance, and in his office it has like a brochure, like why your insurance would go up, and that was on it, so I can see
Yeah.
that.
There's a thing, because we can get, through ours at the school, we can get a deduction every year, and you have to answer this survey online, and they ask you about that. They ask all your, I mean, everything goes into how much do you exercise kind of thing, and I don't know what it, I mean, it's not going to know answering on a computer if you lie or not, but I guess you just have to live with yourself if you're a liar. Don't be a liar. All right, we good on here? There's going to be a few proportion ones. So good that we got an easy proportion one there to wake us up on. Alright, so we'll do this one here. We got Keston's car uses 10 gallons of gas to travel 210 miles. Since I told you we're looking at proportions, let's go ahead and get that proportion ready. 10 gallons of gas, so gallons of gas we're going to use to how far we go, 210 miles. Okay, then it says she has 5 gallons of gas in the car. She wants to know how much more gas she'll need to go 640 miles. So where would 640 fit in the scheme? Bottom. Very good down there with the total miles. What's going to go here? X, but what else? I told you she already had some gas in the car. So that's going to go there. Very good. We got the 5 gallons already in the car. How much do we need to add to it to be able to go 640 miles? Okay, I can tell you I would have to stop and fill up. I can't go 640 miles on a tank of gas. I don't know if y'all can or not. Anybody can go that? That's a long way on a tank of gas.
Yeah,
Yeah, I started.
I think most cars are
I
like
go
3.
400.
even my kid's soul can't do that.
Yeah. Alright, so it is a proportion. We will cross multiply, so that would get us 6,400. Now notice when you cross multiply here, you got to distribute the 210 to both of them. Okay, so that'll be 210x plus, what's 5 times 210? Surprise people.
1,050.
1050, very good. Alright, we got a 2-step middle school equation just with larger numbers. So let's solve this, dude. What we do first? Well, Hayden's all about it. I like it. So 0, 5, 3, 5. Or is it 4? Anybody check me? Come on, y'all hoodlums. Whew! 6,400 minus 1050.
That's right.
Good, thank you. Is equal to 210x. Divided by 210. And tell me how many more gallons Keston's car is going to need.
25.5.
So she's going to need about 25 and a half more gallons.
Yeah, pretty much.
My tank is only 15 gallons, so I would almost have to stop twice in that span. Almost, not quite. Depends on how much I trust that needle getting over there by the E. I don't let it go all the way.
Scary.
I know. I don't want to have to hitchhike or anything.
I ran out of gas at the Springhill red light, and it was my turn to go. And that's like the most busy red light.
Yes, that is a
And it's
congested
right next to a gas
intersection.
station.
Yeah.
People push you into the gas station?
No, I sat there and someone called their husband to get a gas tank and filled it up until I could make it to that gas station. It was embarrassing.
How long had your gas light been on?
Probably a while.
What's the thing now? Everybody's got gas lights. Hey. Alright, it's got a couple of these that are going to involve distance, rate, and time. This is an old standard formula back from the 8th grade. Distance is equal to rate times time. Anytime you're talking about how fast or how long, you're probably going to be using that one. This every time we do this unit in this class, this question shows up on the test or one almost like it. It's talking about a paddle wheeler going with the current and against the current. Y'all seen those huge old Tommy boats? It's got the big water wheel in the back that's propels. Yeah, that's what we're talking about. All right, so paddle wheeler goes 10 miles against the current, and then same time it goes 15 miles with. So we've got our distance, our rate, and our time. Thank you. We're going against the currents and with the currents. Okay? Distance, rate, and time. I'm going to fill this stuff in every time. All right, so here's the info it gives us. A paddle wheeler goes 10 miles against the current. So his distance against the current is 10 miles. At the same time, he goes 15 miles distance with the current. 15 miles with the current. What is this, Grand Central Station? You didn't even look sick when you left. Now you look like you're on your deathbed. Don't go to the office anymore. You come back dying. All right. So we went 10 miles against the current, 15 miles with the current in the same amount of time. All right, this is what we know about the current. The speed of it's 3 miles an hour. Okay? 3 miles an hour is not our rate because our paddle wheel's doing some of the speed and force, right? So if I'm going against that current and the current's 3 miles an hour, it's going to be slowing me down, isn't it? Because it's like, think about paddling your canoe upstream. It's slowing you down. So you got how fast you're going, and you're being slowed down, so you're taking 3 miles an hour off. But when we turn around and start downstream with the current, take whatever you're going, speed it up. Add 3 miles an hour to your rate. That's my kind of paddling there. All right. If distance is equal to rate times time, what would time be equal to? How would you solve this for time?
By hour.
Very good. So it would be distance, good Zane, divided by rate. See that? Distance divided by rate. What we're trying to figure out here, x will be how fast the paddle boat would go if it were on its own with no current. So you can imagine sitting in a perfectly still lake with no breeze or anything, the water's perfectly still, how fast it would go there. It said it went this 10 miles and 15 miles in the same amount of time. So this time ought to be equal to that time, right? So let's set that dude up. Proportion time, 10 over x minus 3 is equal to 15 over x plus 3. When you do that I just did ninja and I didn't ninja. When you do that cross multiplying, you got distributing to do on both parts now because they both have binomials. So 10 times x and 10 times 3 equal to 15 times x and 15 times negative 3. Alright, we got a 4-parter. Pick a part to start. That rhymes.
Minus 45.
Plus 45, Sir Zane said. So that gets us, extend the page. 10x plus 75 is equal to 15x. Subtract 10x. 75 is 5x. Divide by 5. X is
15.
And that would be 15 miles an hour that the paddle boat could go with no current.
Wow. That's great though.
Do you need a smacking? What's your borderline? Getting a little big for his purchase. Good in the hood. Alright, let's do another one. I just wanna go home. Shoo-bop, shoo-bop. No, I'm just kidding.
Line ahead, 5 minutes, the rest,
That's funny that you even know that song.
Well, that's what I got last year for Christmas, because that's all I said I wanted.
Alright, we're at the O'Hare International Airport. We're at the O'Hare International Airport. Cheryl and Bill are walking to the gate at the same speed to catch the flight to Akron, Ohio. Bill wants a window seat, so he's fixing to try to leave Cheryl in her dust. So he decides that, you ever see those moving sidewalks that you just stand on and they like a conveyor belt? He decides he can get on that moving sidewalk and walk and beat Cheryl because she's staying on the stationary ground. Alright. Distance, rate, and time. Bill and Cheryl. Let's fill in some info. Let me get to the gist of it here. The sidewalk moves at 1 meter per second. Bill saves 50 seconds covering the 300 meter distance. Stop. 300 meter distance. They're both going that far. They're both going to the same gate. because the conveyor belt doesn't take him all the way into the airplane. We're just going until we get to the gate. Okay, so we got that. It says the sidewalk moves 1 meter per second faster. So however fast Cheryl's going, Bill's going 1 meter per second faster than that. Attaboy. Now, just like before, to get our time, distance divided by rate. Alright, we can't just set them equal to each other this time because there was one other little bit of info that I told you. Bill saves 50 seconds by getting on the conveyor belt. He's going to beat her there by 50 seconds. Okay? So what we're looking at then when we have this, we're going to have Bill's time, 300 over x plus 1. It's going to be equal to Cheryl's time minus 50 seconds. Right? Makes sense? Now, dadgummit, you don't have just a normal proportion to solve now, all because of this 50 seconds stuck on the end. So we're back to yesterday's stuff now. We need a common denominator. Oh, no, because the 50 is a big number. So I'm looking at the x plus 1 and the x. What do you think on that?
X.
X will be part of it, and?
300 over X.
No?
X plus 1.
Good. Good. We're going to multiply this whole thing by x and x plus 1. Just like if this had been a 2 and a 3, our common denominator would be 6. You just multiply them together. Alright, so when we take this to the first 300, the x plus 1s will cancel out. So you just have 300 times x. When we go to this 300, the x's will cancel out. So you'll have 300 times x plus 1. When we go to the 50, nothing cancels out. So 50 times x plus 1. A few more steps involved on this dude. Let's start distributing. First period, want to know, couldn't you already distribute that? Yeah, you could have written that, already distributed that. That would have been great. 300x equals 300x plus 300 minus 50x squared minus 50x. Okay, we're cleaning up a little bit. Come on, there we go. Like terms right here. So I got 300x is equal to negative 50x squared plus 250x plus 300. Okay, as I combine those like terms, I wrote it in standard form over there. That all right? All right. What's different in this problem than any that we've done so far today?
Squared.
Squared, very good. We got a quadratic, very good, Kaylee. When we have a quadratic, we move everything to one side. We set it equal to 0. This, moving this over, would be less work. I'm so anal about having my squared positive that I'm going to move everything that way. Okay? So I'm going to add negative 50x squared. Now to subtract 250x from 300x, that's 50x. Then I will subtract that 300. Now we're set equal to 0. Alright, you got options right here. You could, because we're trying to solve for x, you could solve that quadratic. Use the quadratic formula. Your a is 50, your b is 50, your c is negative 300. Factor that by doing a times c. Easier thing to do, they've all got a 50 in common. Reduce that thing. Divide them all by 50. Get some manageable numbers. So if I just wipe this thing all by 50, that's x squared plus x minus 6. Much easier to work with. Easier to factor now. Factors a negative 6 that add to 1 are 3 and negative 2. Set both those equal to 0 and solve. If x plus 3 equals 0, that gets you negative 3. If x minus 2 equals 0, that gets you 2. You got a good answer and you got a dummy answer. Why is one good? Why is one a dummy? And which one's which? Remember what this whole problem was about? They're racing to get the window seat. How fast are they getting there? Which one's your dummy answer? Negative 3. We can't go negative 3 miles an hour. X in my original chart stood for Cheryl's speed. So Cheryl is walking 2 miles an hour. When Bill gets on the conveyor belt, he's going a mile, that was meters. He's going a meter faster than that, so he's going 3 meters. I don't think it's in hours either. That can't be right. What was it in seconds? So it'll be per second. Pretty cool, pretty cool. All right, got a work problem to do. We did work problems in Algebra 2. We do them more in this class. When you're talking about work problems, most of the time it's like the kind of question I showed you a video clip in some of my Algebra 2 classes out of a Disney movie where if he could paint the house in this amount of time and he could paint the house in this amount of time, how much time does it take them to paint it together, that kind of thing. So what you got to keep in mind is like if me and Aaron are working together, I'll have the fraction of the time that I can do the job in, the fraction of the time that Aaron can do the job in, then we'll combine those and that will be one complete job. So jobs are always 100%, one will be what you set your sum equal to. And one thing that's important to us on this is 1 divided by time is always going to be the job unit per time. Alright, but anyway, let's read the problem here. We got some good old Haskell names to go with in this one. It says Letitia and Kareem. Run into them at the Grove. Letitia and Kareem were working on a neighborhood cleanup. Kareem can clean up all the trash in the area in 7 hours, while Letitia can do the same job in 5 hours. Alright, so we're going to have here Kareem and Letitia. We're looking at the rates they work. That's just how fast they're working. How long do they work together? I'm going to say WT for working together. And then how much of the job they got done. So we'll say job done. Alright, so it said Kareem can clean up all the trash in an area in 7 hours. So based on this that I told you right here, he's got a 1/7 rate. Alright, Letitia can do the same job. She's a faster worker in 5 hours. So she has a 1/5 rate. It says how long will it take them if they work together? So that's what we don't know right here. We don't know how long they're going to work together. Okay? What do you think we're going to do to get the fraction of the job done? How fast we're working times how long we're working. Wouldn't that make sense? So this will be 1/7 x and this will be 1/5 x. Alright, so when you set this one up now, you've got the amount of the job done that Kareem got plus the amount of the job done that Letitia got, was that her name? I forgot. Is equal to, and this is what I was alluding to, 100% of the job done. One job complete. Alright, this is yesterday's stuff now. What can I multiply this whole thing by to cancel 7 and 5 out? What will they both go evenly into?
35.
Say it again. 35. Good, sir, Verson. So 35/7 is 5. So that would be 5x. 35/5 is 7. So that would be 7x. Nothing cancels here. Equals 35. Well, that's, I got that right. 12x. What we do to figure out their time they work together? Divide by 12. I know it's almost 3 because 36 would be 3. 2 point what?
2.9.
So if they work together, it's going to only take them almost 3 hours to clean up the neighborhood instead of the 5 or 7 that they would have to do it on their own. Common type of problem there on as far as word problems go. Don't forget work, the complete job is 1. A lot of people always struggle with what does it equal there. It's 100% of the job. It's 1 every time. Okay? Alright, I'm going to write did I put the extra question in yet?
No,
I don't see it on Baylor's. I've got it ready, I just got to hit a button. So let me write what the question is and then I'll hit your button. Alright, we got sales tax on a purchase of $1.50 is 12 cents. So we want to know what would the sales tax be on a purchase of $6? Okay, see what I'm asking for? Look at that and make sure you understand what I'm asking for. Let me read it again. Sales tax on a purchase of $1.50 is 12 cents. This is some state, you know, it could be different. What would the sales tax be if the purchase is $6? If I were working it on my own, I'd be setting up a proportion.
I wish. Wait, how much is the original price of item before tax? 150,
Yes.
and then 12 to what?
12 cents is the tax.
So you're trying to figure out how much tax.
Would be on $6 based on that, yes. All right, there's your question. Stop the camera running.
Right. That's where it ended up costing. That's what we usually do. So it means subtract $6, or no, subtract $1.50 from $6. So that